we are going to discuss about what is Fcfs. Fcfs is a non-primitive scheduling algorithm where the process is executed in the order they arrive. Like if I process are there, which process first arrive, it has to be executed completely and then the next process is going to be executed. It is the simplest CPU scheduling algorithm. It's also known as first in, first out. Like first what comes, it has to be get out after the whole execution of that process. Here, what is meant by CPU scheduling algorithm? Here, CPU scheduling algorithm is a method by the OS, like it decides which process should use the CPU next, like which first process one has executed. So next, which process have to be executed is decided by this CPU scheduling algorithm. Many programs want the CPU at the same time, but that CPU can work on one process at a time, like a single core environment. Scheduling decides the order, so every process gets the CPU time efficiently. And what how it works? How it works? Let us see. Process that arrives first gets the CPU first. Each process arrives first, it gets the CPU. After execution, after complete execution of that process, next process will get. Once a process starts, it runs to completion. No interruption until process finishes. Ready queue maintains arrival order. Here, what is meant by ready queue? Ready queue is a waiting line of processes that are ready to run and waiting for the CPU time. And here, two modes of process executions are there. That is non-primitive mode and primitive mode. Primitive mode is that interruption simply. Non-primitive mode is that uh, no interruption, without interruption. Let us discuss. Primitive scheduling is that the OS can stop a running process and give CPU to another process. Example, round robin as a primitive, priority primitive. Non-primitive scheduling means once a process starts, it runs still completion or voluntary stops, no interruption. Fcfs, examples are Fcfs, SJF, and priority. SJF non-primitive and priority non-primitive. Now, let us see the key characteristics of Fcfs. First one is fair, simple, non-primitive, and also first till first out queue. What is fair? No process gets preferential treatment. What process first comes in order, it has to be executed. Simple, easy to understand and easy to implement also. Non-primitive. Non-primitive here, no context switching during the execution. Here what is meant by context switching? Context switching means if there are two processors executing, two processors there. And let's take an example, process A and process B. If the process A is executing, the CPU stops process A, saves its state and starts process B. It is called context switching. In this one, there is no context switching. And FIQ, like use first till first out data structure. Like which comes first, it has to be executed completely, else have to be kept. Now let us discuss the important types. First one is arrival time. Time when a process enters the ready queue. It is called arrival time. Next, burst time. Burst time is the total CPU time required by a process to finish. Start time. Time when a process actually starts running on CPU. Completion time. Time when a process finishes execution. Waiting time. Time spent waiting in the ready queue, which is not running, waiting in the ready queue. Turnaround time. Total time spent in the system. Now let us see the important forms. Waiting time. Waiting time is start time minus arrival time. Turnaround time is completion time minus arrival time. Here completion time is start time plus burst time. Average waiting time. Here average waiting time is sum of all the waiting times by total number of the processes. And as the average turnaround time is sum of all turnaround times by total number of processes that has to be executed. Next, let us discuss the advantages and disadvantages of the Fcfs. Now, first advantage: simple to understand and implement, fairness, with low starvation, low overhead list. There is no over complex calculations and predictable behavior. We can predict it easily. Here, what is meant by starvation? Starvation happens when a process waits indefinitely and never gets CPU time. Actually, it has to be happening prior to scheduling. Like if new high priority process keeps arriving, a low priority process may never get it done. But in this Fcfs, there is no problem of starvation. Like every process will get the CPU time. Every process is going to be executed. Next, the disadvantages of FCFS. Poor average waiting time, not suitable for time-sharing systems, no consideration for process priority or burst time. Which comes first? It has to be executed. What is meant by here? What is meant by time-sharing systems? A time-sharing systems allows multiple users or processors to use the CPU by giving each of them a small time slice, like make everyone feel like they are running simultaneously. It was Apple in round robin scheduling, as these are not suitable for the FCFS. And the main disadvantage is callway effect. Callway effect means short process wait behind long ones. Like actually, callway effect mainly occurs in first come first serve scheduling goal. Well, a long job arrives first, all the short jobs get stuck behind it, causing delay. Now let us take the example of callway effect example. If P1 has burst time 20 and P2, P3 has burst time 2. Without FCFS, the shortest process like P2, P3, first P2 executed, L3, P3, L then P1. The average waiting time is 2. With FCFS, with this callway effect, the log process P1 has to be executed L then P2, L then P3. So log, L then log, L then last one. Your average waiting time has been increased. Because of that, the average waiting time has been increased. Now, let us discuss the first CPU scheduling algorithm. As we are going to execute the first this FCFS in our Python language. In our Python language, the whole Python language, we are going to be execute this one. Now, let us discuss the execution of the FCFS. Now, here I am going to explain the every line of the code. Now, here we are defining the FCFS. Here, this defines we are defining this FCFS is the name of FCFS. Here, this represents all the scheduling logic is mapped inside this function, inside this FCFS function. Now, let us go into this one. Here, we are defining a variable and we are giving int of input alter number of process. Like your input means the Python input here means gets user input as a string as it converts into the integer. Like if we alters 4, number is equal to 4. Here we can alter the number of processors. And here in this one we alter the processes and the burst time in the form of the list. In the form of the list. So we have to give process is equal to 1 empty list and burst time is equal to 1 empty list. And then we have to execute this one. Like we have to run in the for loop. Like here for I in range of number. Like we are giving the number of processors, right? In that one we can run that program. Here the loop runs levels to collect the burst times. Here we are appending the process. Like append means we are adding the process one by one. We are adding the process one by one. I plus 1 ensures process ID starts from 1, not from 0. In I plus 1 ensures process ID starts from 1, not from 0. And also therefore we use burst time like burst time is equal to int of input alter burst time for the process P of I plus 1. Here we are altering the burst time for the above processors. By altering that one, we can append like we are adding the burst times. Next one. For example, if number is equal to 3, if for example we are giving 3 processors, like we are alter burst time for the process P1, alter burst time for the process P2, alter burst time for the process P3. After altering process P1, P2 burst time for the process P1, P2 and P3, it going to append. Like you are going to add that one in this one. Next, waiting time and turnaround time. Waiting time is how long process waits before execution. Turnaround time is total time arrival to completion. Illustrate two lists with a number zeros here. Initially we illustrate with zeros. Next, we are going to calculate the waiting time, turnaround time, waiting time. Here for I in range of 1 to number. Always the process starts from 1 to how many number of process we are given. How many number of process we are given. Here the waiting time of I is equal to waiting time of I minus 1 plus burst time of I minus 1. As this loop calculates the waiting time for each process. First process that I is equal to 0 as waiting time of 0 is low wait. That's why the process always starts from 1. Each subsequent process waits for the sum of all the burst times of previous process. Let us take an example. If the 3 processes are there, for the 3 processes, the burst time are 5, 3, and 8. Then the waiting time of 1 is 5. The waiting time of 1 is 5, and the waiting time of 2 is the previous one, 5 plus 3, that is 8. Now, let us calculate the turnaround time. For a range of number of processes we given, turnaround time of I is equal to waiting time plus burst time. Waiting time plus burst time, it will calculate. After that, we can print. We can print the process, burst time, waiting time, and turnaround time in the form of table. Like for example, here print say header, like in a slash l represents print say header for the output table, and also and slash t represents add tab spacing for lead alignment. Like here, it will automatically give space for each of these one, like process, burst time, waiting time, and turnaround time. After completing all these, we are going to run a loop. Like we are going to run for I'll range of number. We are going to print the all these process, burst time, waiting time, and turnaround time, and the output of the whole solution of the process. And also we are going to print the average waiting time and average turnaround time. Average waiting time is sum of waiting time, sum of waiting time by total number of processes. Here average turnaround time is sum of all the turnaround types that are there in the process and total number of processes. And at last, we are defining defining means we calls the function and starts the scheduling simulation. Now let us see the execution of this one. For this one, first the whole code interpreted in the file called nano fcfs.py. So we have to first click the control X. Now we are executing this process. For that, we have to click Control X to exit. Control X. Now we see what is Fcfs, how it works, key characteristics, importance, formulas, advantages, disadvantages, and also the whole execution of our Fcfs. Now we are going to exit. For exit, we have to click the Control X. For running, here I have saved the file in the Ubuntu terminal with nano fcfs.py. As we are doing in the Python, we have to save the .py. And also I am going to run this file. For that, we have to click Python 3 space. What is the file name we give? That has to be, we have to click fcfs.py. Now we have to enter, and we got enter number of processors. Like if we enter 6 processors, enter the, as you see, as I explained, we have to enter burst time for the each process line by line. Let us enter the burst times like 2, 5, 7, and 8, 9, and 3. As we got the process 1, 2, 3, 4, 5, 6. For the 6 process, we have given burst times at 2, 5, 7, 8, 9, 3. For this, the waiting time and the turnaround time in a perfect table with a perfect gap has been kept, and also the average waiting time and also the average turnaround time has been kept. So this is called FCFS in the Python execution. Thank you.